Hello everybody, welcome to my channel. In this video, I'm going to go through this Leetcode 2007 find original array from doubled array. So this question was asked by Google in the past 6 months for 15 times. Let's dive in. An integer array, original, is transformed into a doubled array, changed by appending twice the value of every element in original, then randomly shuffling the resulting array. Given an array changed, return original. If changed is a doubled array. If changed is not a doubled array, return an empty array. The element in the original array may be returned in any order. So let's look at some example over here. The changed one is 1, 3, 4, 2, 6, 8. So the input is 1, 3, 4. And because we can double the 1, we get 2, right? And then we can double the 3, we can get 6. Double the 4, we can get 8. That's why this changed array can be coming from the original input array, which is like this. And we have to write a function to find this output, which is the input to be fed into to the doubled operation to get this changed array. And this is some explanation, right? This is basically what we just discussed, and we can return the array in any order we want. And in this one, we have to return an empty list. Basically, we cannot find a original array that is to be doubled to arrive at this one. And in a case where we have only one number, and that will be empty list. So from this, we can see that if the length of the array is an odd number, it's gonna be an empty list, right? It's impossible to have a array to be doubled it and to arrive at the changed array, right? So straightforward enough after the first glance. Actually, there are a lot of edge cases I'm gonna discuss with you along the way. Let's discuss some approaches that's possible. We can have a brute force approach. We can scan through the array. So for each the number in the array, and find if the x divided by 2 or x times 2 is in the list or not. If we find it, we can append the smaller number, right? Because the original number must be smaller, right? To the result, and then we move. At the same time, we can remove the x and the counterpart away from the array, so we don't do double counting. If we don't find the counterpart, and we immediately stop the algorithm and just return the empty list. And the time complexity is going to be n squared because we have to find each one of the counterpart, right? And so this is possible, but this is not very efficient. And improvement, we can use a set or you can use a hash map. And that we can do a big O(n). Let me show you how can we do that. And first, we're gonna cover the edge case where if the length is 0, which means it's an empty list given, and or the length of the array is a odd number that we talked about. So in that case, it's impossible to find the original array, right? We just return a empty list. And now we have the result list defined in here, which is empty list, and we call the collections. So basically, this summarizes the statistics of the occurrence of each of the numbers. I call it count. Okay. So basically, it summarizes the occurrence, right? The first number occurred 1 times. The number 3 occurred 1 time, right, etc. So this is the key to solve this problem, the counts dictionary. And now we want to address some another edge case where if there are pairs of zeros in the number given, right? So let me show you what actually this block of code addressed, right? I'm gonna comment this out and then submit it, and then you see exactly what I'm talking about. So if the given list is like pairs of 0, actually this is legitimate, right? So however, it's 0 is kind of unique in the case where 0 times 2 is equal to itself, and 0 divided by 2 is equal to itself, right? So how can we solve this edge case? So if there's some count for 0, right, in the original count, so count.get 0. So if this number is not none, and also the length is a even number, that means we can find pairs, and then we just append 0 times, because we're talking about pairs, right? So we can have um, the total number of zeros divided by 2, again pairs, and we take the integer of it because we have to clone the 0, right, and then extend to the result. And after that, after we've done the work, and then just zero out the count, so we don't have to worry about them in the rest. And otherwise, in the case where the length, I mean the numbers of zeros is odd number, so that means that it's impossible to double them in the doubling operation, right? So we immediately stop the program and then return the empty list. So this block of code covers this edge case. So let's go through the rest. And now we have to sort the count dictionary by the key. So the reason why we have to do that is to let me show you why. So if you don't do the sorting, actually it covers most the test cases, but not all. Let me show you why. So in the case where, for example, 4 times 2 actually is 8, right? But 4 divided by 2 is 2, and 8 times 2 is 16, but 8 divided by 2 is 4, right? So basically they are like these pairs are interconnected. But if we go through this array in this order, that means like 4 matches with 8, 2 matches. Hold on, maybe yeah. So 4 matches with 8, 2 matches with 1, and 16 matches with 8, which is okay. However, if we do 4 matches with 2 and the 8 matches with 16, and then what we are left with is 1 with the 8. In that case, A cannot match with 8. No, sorry, 1 cannot match with 8. So that would be a non-solution, right? And that's wrong. Actually, we do find a solution for this. So a way to solve this is to just sort them, right? Let me show you what I mean by that. So as you can see on Notepad here, this is the original array over here, and this is the one sorted, right? So if we sort it, and this one will be matched with this one because this pair, this number 1 will be dealt with first, and then this number will be dealt. So now this pair is have been dealt with, so we can remove them, right? And this is the second number that we are dealing with, and this number is matched with this guy, so it's done. And this number matches with this guy, so it's done. So if we sort the dictionary by the keys, and then we can find a solution for this edge case. And that's exactly why we need to sort them. Let me put it back in. And this one takes big O k log k. So k being the number of unique integers. So now let's do the rest. If the count for the x that we're looking at is greater than 0, and so we have two cases that we are addressing over here, right? If the x divided by 2 in the count keys, and also if the count for the x divided by 2 is greater than 0, and then we find the minimum length. So basically this is the minimum, I've called it minimum count, but you get the idea, right? So what's the minimum we are taking? We're taking at the count for the x itself, also the x is the counterpart, which is x divided by 2, and then we pick the minimum of it, and now we are generating all the numbers divided by 2 times the minimum length. And after we've done the work, we just decrease the count by the minimum counter that we walk through. The reason why we are doing this because there will be a case where there will be repeated pairs. And when the pairs are repeated, we cannot deal with the pairs one by one. So we have to do all of them all at once. And this is the workaround. So consider we have a list like this, right? 2244, which is a legitimate input, and the count will be 2 has a occurrence of 2, and 4 has a occurrence of 4. So basically we have 2 pairs. And now we have the mean length. Basically we look at the count at the 2 and count the 4 and take the minimum of it. In this case they are same, right? In the case, I mean, one possible solution would be like this as well, right? And this one, and that the actual 4 will not be taken care of, right? So if the case looks like this, and we have the 8, right? So we can deal with these 4 numbers all at once, and this one can be dealt with separately, right? So, and also we have in this case we have 3 occurrence for the number 4, right? Also with the 8 occur once. Okay, so we take the minimum of the 2 and 3, right? Which is 2 in this case. So we have the mean length of 2, and then we extend the smaller number, and then repeat it by the minimum length, and then extend it to the result. And now after we have to deal with these 2 cases, well, 2 pairs, and then we reduce the occurrence in the counts dictionary. And after that, I mean, after this operation, right, the count dictionary will become something like this. So that we can deal with this case where 4 and 8 should be in a pair. And that's why we have to write such a block of code to deal with this in the case where they are pairs. And very similarly, on another case where if we can find the x times 2 in the count, right? Basically, it's the same operation, right? It's just changing from x divided by 2 to x times 2. In a case where if we cannot find a counterpart, which immediately stop the entire program, just return the empty list. So after we finish the iteration, and if there are some value cannot find the counterpart, we just return the 0 immediately. Sorry, yeah, compared to 0 means basically if in the case, sorry, let me say again. So if the leftover count is 0, that means we have find all the counterparts for all the numbers. We find all of the numbers in pairs, right? And then we can return the result that we're working with along the way. Otherwise, means that there are some numbers cannot find their counterpart, right? There are still some numbers in the occurrence in the counts dictionary that we have not yet dealt with. Remember, each time when we work with one pair or number of pairs, we just decrease their occurrence by this one, right? Minus equal, right? And if for some numbers we cannot find their counterpart, we just return empty list. Submit that. And it works. So for time complexity, you can see it's big O of k log k, and also big O of n, because we basically iterating the number of possible value count pairs, right? So basically it's big O k log k plus big O n. And for space complexity, it's going to be big O n, because we have the count over here. And this is my solution. I hope you find it helpful. If it is, please like and subscribe. Thank you so much for watching. I will see you in the next one.